Hello everyone, welcome back to the channel. I hope you guys are doing amazing. In this today's daily challenge on Leetcode, I will show you two approaches to solve the problem, starting from O of n log n to O of n. We will optimize it to something like 2 of O of n. So stay till the end of the video. Okay, so let's see what is the question. uh, Reschedule meetings for maximum free time. This is the second part of the problem. In this problem, you are given some intervals in which meetings are held, and these intervals always lies from 0 to this event time. This event time is the ending limit. Okay, and as you are given the start time and end time of each and every interval. You see, you have given two vectors, start time and end time. You can reschedule in this version of the problem. You can reschedule at most one meeting by moving its start time while maintaining the same duration. It means that you can pick the one interval, any one interval, and move it to some other place. You can even change the order of interval while doing so for this version. And what you need to do is maximize the longest continuous period of free time during this event. So what will be the maximum continuous free time by doing this shifting? You need to tell that. So if you see, uh, this interval as it is given in this question can be shifted towards right or towards left. The same for this, but if you see for the third example, this interval which is given by 7 to 8, you can pick it and shift it to something like 1 to 2 also. Okay, not just move it right and left, you can just completely jump it to 1 and 2, and you will end up in getting some larger interval. If you try to do something like you pick up this interval 3 and 4, and you make it jump 8 to 9. Okay, then you see you are getting much larger interval, right? 1 to 7 you are getting free. You are getting a free time of 1 to 7. So that is 7 minus 1, that is 6. You are getting a free time of 6, and therefore your answer is 6 here. I hope you understand what the problem means now. And before watching the solution, you should definitely try it on your own. You do not need any special data structure for this, only vectors and arrays. And you can solve it in O of n time also. So let's see about the question. Okay, so the first thing which should come to your mind is that you should draw a timeline first from 0 to t. Timeline from 0 to t, to in order to visualize what exactly are the things which are going out. So uh, so let's see. Let's say this is one meeting, this is one meeting, start time and end time, this is one meeting, and this is one meeting, and these are the free times or the gaps. Okay. So what you do is that then you should think that these are the gaps which we want to make it continuous by shifting some meetings. So the first thing you should visualize by drawing this, and the thing which should come to your mind is that I can move any interval, but let's say I am moving this interval for now. Let's say I'm moving this interval for now. Then I have two ways to move this interval and make the gap which is there in between large. How can I make them large? Let me shift it to the left. Then what I will get? I will get something like this. Tell me if you agree with me or not. If you try to shift it towards your left, let's say you will get it attached to this left bar, that is, and you will get something like this. And maybe this is your maximum time, maximum free space. Okay, maybe this is your maximum free space. If you are choosing to move this block, okay, this is the first way. There is also a second way in which you can move this block. If you can jump this block to some other place, then the whole space you will be saving, right? But you can only jump if some other space can fit this block. So if the current block, let's say I'm iterating through all the meetings from I equals to 0 to n minus 1, I will check if this can be fitted into some other space. Then you can jump it, right? So let's say if you are jumping it to here, what will it become? Can you tell me just, can you draw it on your own? Try to draw it on your own. You will see that you will get the whole space here, and maybe you will get something like this. You have jumped, which was here, you have jumped it to this. Okay, so I hope you understand this. I hope you clearly understand this. And now maybe your free space is this, which is definitely greater than something like this. And so you see, you need to just check out of all these, what are the things which are going to happen? What are the things which are going to happen? So, uh, and also about the gaps array, right? About the gaps array, what do I mean by the gaps array? These are the gaps which I am bothered about. So do you now you try to visualize in your next step of the problem. So now comes the step 2 of the problem, which you should think in your mind, is that what will happen to these gaps array if I try to do both of these operations? So you see, let's say this gap was something like, let's say 1, this is something like 3, let's say this is something like 2, this was something like 2, this was, let's say, something like 4. So I have the gaps array which is given by 1, 3, 2, 2, 4. Okay, I hope you understand this. I hope you understand this easily. And let's say the length of this meeting is 1. Let's say the length of this meeting is 1. So what you can do, this is your gaps array. After shifting this, these two elements get added up. This becomes 3 plus 2, 5, and this stays 1. This gap stays something like 3. This gap stays something like 4. So all the gaps stays the same. Just two continuous gaps get added up. I hope you understand this, right? I hope you understand this. So this is the thing which happens. Remaining 2 and 1, 2, 4, 1, 2, 4, that remains the same. That remains the same. So this is something. Okay. And what will happen in this case? uh, 3 and 2 will definitely get added up. What this will get me, something like 1 6. This will be 1 6, and this will be something which I am not bothered about because it will be definitely less. Okay, this will be definitely less. So what I can do is that if I am able to shift, I will shift and check that if I can get this. So how I have got this 6? If you try to wonder, 3 was there, this portion was 3, this portion was 2, and the length is 1. So what do I get exactly? If I am iterating through the ith if I am iterating through the ith interval, you can say that my if I am jumping my case, in the case where I am jumping my event, it is given by the left gap plus right gap. The length of the left gap is what? It's 3 here. The right gap is 2 plus the length of the event plus it is nothing but the length of the event. That is nothing but 6. That is nothing but 6. And here only the two gaps are getting added up. So what you can do, you have, I guess this was there for yesterday's problem also, this approach. Okay, the only thing which is added is this new approach. So first of all, this is a window. You will maintain a window length of 2. So what do I mean by window length of 2? You can remove any of the blocks, right? You can remove or shift any of the blocks. So first you will get, let's say you keep an answer variable. You need to maximize your answer, right? You keep an answer variable to 0 and you need to maximize your answer. So what can you do to maximize your answer is that first you take care of this case 1, in which, let's say, your gap array was something like 1 3 2 3 4. So what you can do, you can try shifting all of these gaps. So let's say if you try to shift the block which is there in between these two gaps, you will get something like 4 2 3 4. I guess these two will get added up. Okay, and now in this case, this similar to this case, where, let's say, okay, so first of all, this was nothing but 2, right? To make the things very clear, I am just doing this was nothing but 2 in our previous example. You can take it, I mean, you can take it anything, but this was 2 in our previous this example. So now you see what you can do is also 1 5 2 4. Also another thing which you can do is 1 3. You can merge these two, right? Now you can merge these two. So 1 3 4 and 4. What you can also do is merge these two, 1 3 2 and 6. And you will, every time you are merging, let's say you are getting this by merging, then you are getting this by merging, then you are getting this by merging. Okay, so you store the maximum value, you keep updating the maximum values by doing, how to maximize your answer, right? You know how to maximize your, so doing something like this, you just store it in your answer. So this, after doing this, you took care of the first case. You took care of the first case, that is by shifting. Now jumping. Now you need to take care of the jumping. Okay. Uh, how will I ensure that I jump correctly? I jump correctly. Only I can ensure only if the thing is that then I should have the space to jump to. Okay, I should have the space to jump to. So what do I mean by it is that, let's say you are jumping a particular block. Okay, let's say you are trying to jump this middle block. Okay, you are trying to jump this block to some other place. So first of all, you should see that there is a sufficient gap or not. You there's Let's say there are intervals here, so you are traversing through all the events and you should check that there are sufficient gaps or not. Okay, so you have the gaps array created, right? You are having the gaps array. So you first of all, uh, you see there is a left gap, there is a right gap, and there is a gap which you want to jump to. So why don't you select the top three gaps? Top one, top two, top three. You select the top three gaps. So what you can do is that you have the gaps array with you, right? You have the gaps array with you. You reverse sort it. Reverse sort the gaps array. After reverse sorting it, you can select the first three elements. Okay, you select the first element, second element, and third element. Those are your top three gaps. These are your top three. So, what I want to say is that the thing which should come to your mind is also, let's say you are moving this block to some other place. Okay, instead of moving it, shifting it to the right or left, you are moving it to some other place. So you are trying to fit into some other gap, and you want to check that whether my gap is sufficient to move or not. But this is also a gap. This is also a gap. You do not want to move in these two gaps, right? You want to move in some other gaps. So you see that apart from these two gaps, are there any other gaps which I can shift to? That's why I need the top three, because there are many cases, right? First case can be, let's say, the best gap, the top one gap is this. Okay, and let's say the top two gap is somewhere else. This is the case one. Case one is that top one gap is my left gap, but I do not want to shift this to my left gap. I want to, since I am jumping it, I want to check whether I can shift it to some top two gap or not. This is one case. There is an another case also, is that uh, let's say let's say you want to jump to some other gap, and this is your first best gap, largest gap, and this is your second best gap. Then you do not want to jump here or here, you want to jump to some other gaps. So you take the top three gap and you see whether this gap is greater than or equal to my event size x. Okay, the same you do here, whether this event size x, top two gap, is greater than your event size x. Similarly, very similarly, there can be another case, is that none of the element is your top one and top two among your left and right. Okay, so what do I mean by it? This, the top one, the best gap is present somewhere else, not in here, not in here. So what you can do, you can just check whether your top one gap is greater than your x, your best gap is greater than your x. So I hope you easily understood this, right? What we need to do. So let's recap everything. You want to move, you will move through the events, and you want to move an event either by shifting or by jumping. For the shifting case, you can see that the gaps array is getting merged by elements of 2, by a window length of 2. This is getting merged. So you can easily you can easily iterate through the array and take two sums and maximize your answer. This answer you should more maximize by doing this jumping case. Okay, but how is the jumping case characterized? It is characterized by left gap plus right gap plus event. You get this whole length. How can you jump? You need to ensure that you are not jumping within the left gap or right gap, you are jumping to somewhere else. For that, you need the top three gaps. Let's say the top one gap is in my left or in my right, then I want to jump to the top two gap. Okay, and my top one and top two both are in my left or right, then I want to jump to some third best gap. Okay, If none of them is in my right, I want to jump it to some definitely the globally best gap, definitely to the globally best gap. And that's everything, that's everything you need, the intuition to solve this problem. Okay, so let's see the solution for this. Let's try to see the solution for this. And I will try to do it quick. So this start time dot size is nothing but n. Okay. I hope you will easily understand how I am creating this gaps vector. You can do it on your own also. You can do it on your own. It's very simple actually. So you have a previous value 0, and you just for every interval, you just do gaps dot push back my starting point, my starting time minus my previous value. I am just using this method, and I am updating my previous value by the end time also, end time of I hope you understand this, how I did this. If you did not, just check it out. Is that what I am doing? I am creating the gaps array, this 1 3 2 2 4. What I am creating, initially my previous value is initialized to 0, so this is my 0 previous value. And what I am doing is that I am making these gaps is nothing but start time. This is the start time minus my previous. Again, when I am in this interval, I am checking what is the start time. I update my previous to this, then I update my previous to this. I always keep updating my previous to the end time. Okay, I keep updating my previous to the end time, and I do something like start time minus previous. This is my gap length. Start time minus previous, this is my gap length. So I am adding the start time minus previous into my gap length. And I hope you easily get this. But well, what if your previous is at the last? You need to do t minus previous. Okay, so one gap, just push back the missing portion. Okay, so last portion actually, pushing back the last gap. Okay, will be something like it will be end event time, the whole event time, minus this previous. Here you are doing nothing but pushing the last gap. Okay, we are missing out the last gap, so just put it. Okay, so what you see now, you have an answer 0, and you need to maximize this answer for so I am doing the case 1. I am doing the case 1. Case 1 is that block is getting shifted. Block is getting shifted. Okay, uh, for the block to get shifted, I need to have a window length of 2, right? So it is very simple. I do just do the gaps dot size minus 1. Why I'm doing minus 1? Because I am doing nothing but maximizing the answer, which is nothing but gaps of I plus gaps of I plus 1. I hope you understand this, what I'm doing. Every window length of 2, I'm just adding these gaps and telling that it can be my answer if I shift. Now my shifting case is completed. Case 1, the block is getting shifted. Now I need to find the case 2 where my block is getting jumped. Okay, I need to be very careful while doing this. Block is getting jumped. I need to be very, very careful while doing this. Why? So first, as I told you, I need to sort, right? So let's take another vector and just copy it. Let's say sorted gaps. This vector is nothing but sorted gaps. I just copy this, and I do something like sort is gaps dot r begin is thing which you need to do for reverse sorting, and is gaps dot r end. This ensures that it gets reverse sorted. So I now get my top 3 elements. My top element is nothing but the first element of this reverse sorted array. Top 2 is nothing but this is gaps of 1. Top 3 is nothing but this is gaps of 2. Okay, I hope you easily get it. I hope you easily get it. These top 3 gaps you are having with you. You are having with you these top 3 gaps. Now, what you should do, you should check for the left case and the right case, right? Now you need to be very, very careful with this. You are iterating through all your events. Okay, you are iterating for all your events, and now you want to jump that particular event. So first of all, what is the left gap? What is the left gap? Can I tell you? Can I tell something that the left gap is nothing but gaps of I, and the right gap is nothing but gaps of I plus 1. Why is this? Why is this? I hope you understand it, right? What is the left gap of this? Let me draw some neat thing. Okay. Uh, let's say, yeah, in this only I am explaining. Uh, let's say this is your left gap, this is your right gap. Okay, so what is this? This is the first gap, this is the second gap. So if you are in the ith block, the ith gap will give you the left gap, and the I plus 1th gap will give you the right gap. Okay, I hope you easily understood this, how it's happening. You are in the ith block, you are in the second block, so the second gap will give you the left. So that's what I'm doing. Left gap is nothing but I, right gap is nothing but this, and the event time is nothing but my start time minus end time minus start time. Okay, so it is nothing but the end time of I minus start time of I. So I hope it was clear. Okay, so now what you can do, what you can do, you need to check that whether I can select the top one element or not, whether I can select the top one element or not. Let me have a boolean value for that. Select one indicates whether I can select the top one element, first element. This indicates whether I can select the top two element, the next element. Okay, so listen to me very carefully. What I do next is that this left gap and right gap, we need to find the maximum and minimum value among those, right? So let's say the maximum value is nothing but max of left gap and right gap, right? I'm just selecting out, I'm just taking out whichever is my maximum as well as whichever is my minimum. Okay, now, you tell me, as I had explained you earlier, that uh, what are the three cases here? The first case is that I can select the top one. Let's say I'm starting with the third case. I can select the top one. When will that be true? My left gap and right gap both are not the top one. That the maximum among my left and right is not the top one. So, if the maximum value is not the top one element, then I can select one which is high. It means that I can select this. Now I can select this. Okay, if my if my maximum value is not in the top one. If it is okay, then I will go ahead and check whether I can select one. Okay, then I will go ahead and check whether I can select two or not. So now I will check that if my minimum value is not equal to the top one. So if you are in this else loop, it means that your maximum value is in top one. So this is the case which I am talking about now. Case two, case one. This top one, this maximum among these two is in your top one, and you are going to check for the top two or not. And if it is not in the top two, then you can select it. Okay, if minimum is not in the top two, then you can select it. Okay, now you can do what you can do is very simple. You just see that if I can select one, what will I do? I will just update my answer equals to nothing but answer comma max of left gap plus right gap plus event, the whole event. I'm jumping it, right? This is the case where I'm jumping it. So that's the thing, this why when will I do? If I see that if my top one, if my best gap is greater than or equal to my event, if my event can fit in, then only I need to do this, right? Otherwise, how I can fit in, right? So else if you see, if I can select two, if I can select two, and then I need to check whether this top is giving me greater than or equal to this event. So if my answer is nothing but max of, then answer left gap plus right gap plus event. This will be same everywhere. This will be same everywhere. Else I will select the top three. Now I need to check whether my top three, the third best, is greater than or equals to, still greater than or equals to event. If that is the case, I can update my answer in exactly the same way. That is, I can simply jump. I can simply jump, right? So I just now copied this. So let's copy it again. Yeah, I just copied it. And if you see, we are done. We have updated our answer For the case 1 also, we have updated our answer. For the case 2 also, now we can just simply return the answer. Let's check if I have done any error or not. Let's check I have done any error or not, or is everything truly correct. So you see we are getting a wrong answer here, so there must be some logical error, some kind of logical error which is happening. So let's try to see it. This answer is getting updated, and this is nothing but cat's eye. You just select the top three elements, select the maximum and minimum amount. So you see, I have done a very silly thing here. I have not written the minimum function correctly. So if you try to run it now and check, you should get accepted. Let's try to submit it and check what is our percentage bits. So this is an O of n log n solution, right? And you see the runtime is not so great, not so great. So can you optimize it to O of n? Since you are sorting it, can you optimize it to O of n? Definitely you can, right? So you see we need the top three elements. So for getting the top three elements, do you think we need to sort the whole array? What is the point of sorting the whole array when you can easily get the top three elements? So without creating this S gaps array also, I can easily get my top three elements. How can I do this? It's very simple. In the beginning of coding, you must have learned it something like find the first max and the second max element among the whole array. There, it's nothing but the first max, second max, and the third max. So you go through your gaps array. You go through your gaps array, and in whichever way you want, you just find the top three elements. So how I will do this? I will check that if x is greater than or equals to this top one. Okay, so I have a new top one. It means that my top one will get updated to x, and my top one has now moved to top two. My top two has now moved to top three. I hope you understand this, right? This is nothing difficult in this. Else if you see x is something greater than top 2, it means that it is not greater than top 1 but it is greater than top 2, then my top 2 is getting updated to x. In the process of this, definitely my top 3 gets shifted to top 2. Okay, top 3 is now top 2 because top 2 has a new value. And if none of this is the thing, if it is something like x is greater than or equal to top 3, then you do something like top 3 is x and you do not need to move any other values. Okay, I hope you understand this. I hope you understand things, and I don't think I have done any error. Let me try to run and check. So you see in O of n, you get to get the top three elements easily. If you try to submit it and check, will I get any better runtime and memory complexity? I think I should definitely get. What do you think? Let's see, you are getting a better runtime and memory complexity. You are in the top submissions almost. So yeah, when I submitted it earlier, it was giving much better than this also. So you see 85%. So it varies, but it is in the top portions. It is in the top O of n solution which you have done. So yeah, that's all. That's all for this problem. This was a medium kind of problem for today, but I hope your day will be very easy. Thank you so much.